Hello everybody, this is Lord Artorius Collbrande, aka Lord Daios Legentachtis, as I'm going to futurely call myself on this channel, and today we're going to be discussing perihelion and aphelion distances with planets and how to actually solve this equation. And we're going to be doing it to solve the perihelion and aphelion distances of Jupiter. I decided to make this video today because not only do I think it would be helpful to a lot of people if they're taking an astronomy class in school or college, but I just wanted to make this video today because I thought it would be really cool to share to the entire world my knowledge and what I know about astronomy. Learning about astronomy is a fascinating subject to me, and I love talking about a lot of cool stuff that's out there. So I just wanted to do the world a favor by sharing cool knowledge and facts about this subject. Today we're going to go over how to solve and get the answer for what are the perihelion and aphelion distances of Jupiter from the Sun, and understanding what those terms actually mean so you understand what they are and what those terms actually mean. With that in place, let's get on to the main subject at hand. So, a bit of context before we really get started discussing this topic. In order to comprehend and understand what these terms actually mean by their definition, it needs to be addressed that it was discovered during the early 1600s by a legendary astrophysicist scientist known as Johannes Kepler, that planets don't orbit the sun in perfect circles. While it definitely became true being discovered that all planets in the solar system orbit the sun, destroying what the geocentric model of the universe believed was the order of all things revolving around the center of the cosmos, the scientist Copernicus was wrong about only one thing. According to Kepler's 3 laws of planetary motion, his first law states how all planets move around in ellipses around the sun. And his second law is that planets move faster when they're at a point closer to the sun, which is their perihelion distance, and slower when they're at their farthest point from the sun, which is their aphelion distance. In other words, there are times when a single planet is closer to and farther from the sun, and different times throughout the course of their own orbits. It's definitely fascinating to think that a planet can move in an irregular shape closer to and farther from the sun, almost like you'd think somehow that the planet is breaking from its own orbit and free traveling across the universe. To fully understand what perihelion and aphelion are now, it needs to be concretely explained what it is exactly they mean. Perihelion is the closest point to a planet is to the sun during its orbit, and aphelion is the furthest point a planet is from the sun during its orbit. And this is all for a single planet. Keep that in mind. And not, all the other planets and talking about their orbits. Not to be confused with that concept. There's a simple mathematical formula for figuring out each perihelion and aphelion distance of each planet. In order to figure out perihelion distance, you have to take the semi-major axis number and multiply it by putting in parentheses 1 minus the planet's eccentricity of its orbit. For aphelion distance, you would instead put 1 plus the eccentricity of its orbit in parentheses instead of minus. In order to solve this problem, we need to know the semi-major axis and eccentricity of Jupiter's orbit. Jupiter's semi-major axis is 5.202 astronomical units, rounded to the nearest thousandth in distance from the Sun, which means A equals 5.202. Jupiter's eccentricity, on the other hand, is 0.049, rounded to the nearest thousandth. So E equals 0.049. That means in order to figure out the perihelion distance for Jupiter, we have to do 5.202 times, in parentheses, 1 minus 0.049. And for the aphelion distance of Jupiter, we have to do 5.202 times, in parentheses, 1 plus 0.049 to get the answers. Doing the math, Jupiter's perihelion distance is about 4.947 astronomical units, and Jupiter's aphelion distance is 5.457 astronomical units away from the Sun. Just to go over what an astronomical unit is, 1 AU, astronomical units, is the equivalent of 92,960,000 miles. That means Jupiter's perihelion distance is 459,873,120 miles. And Jupiter's aphelion distance is a whopping 507,282,720 miles away from the Sun. Just to put that all into perspective, and just remember, 1 mile alone is already 5,280 feet for good measure. Thanks for watching. I really hope that this video was helpful in teaching people and helping them understand what perihelion and aphelion mean with their definition. I hope this video was a lot of fun watching, and I hope it was an awesome, informative, and cool video. Astronomy is such a fascinating subject, and I just wanted to share my knowledge with the rest of the world. I hope this was good at informing statistics about Jupiter's distances from the Sun. Thank you so much for watching. Please like and subscribe, and stay tuned for more exciting and awesome content on this channel.